We know that soil and water quality is essential for land productivity, crop production systems, and protection of our environment. Digital agriculture and technology, innovative research, and farm production practices have the potential to reduce nutrient loss, minimize soil erosion, and improve or sustain water quality. Let's examine some of the production practices around soil and water quality.
So I'm hearing, profitability and yield, is a huge part of some of the outcomes. You talked about defining outcomes in regenerative agriculture. What are some of the other outcomes that folks are defining?
Yeah, so soil quality is a big one. And soil quality can be measured in a lot of different ways. There are short-term metrics that will change, in a matter of months or years, and then there are longer-term metrics that change more on the course of decades. And that's one of the things that soil scientists have been learning, is that some of the more classic measures of soil organic matter, for example, really don't change in the course of years. They change in the course of decades. And so trying to find appropriate markers for progress at different timescales has been critical. Soil biodiversity and overall non-crop biodiversity in agri-ecosystems is another important goal. So if we're going to be managing 120 million acres of corn and soybean across the north central region, how do we do so in a way that allows for some non-crop biodiversity, since we're going to rely on these ag lands to be doing some of that work of providing habitat? How do we make sure that that happens? Clean water, clean air, limiting nutrient loss through drainage, limiting unwanted emissions, either carbon or nitrogen emissions, and then economic opportunity and equity in rural communities and urban and peri-urban areas that are also part of the value chain.
It's a question that every farmer will always tell you that they've never faced more regulation. Every input supplier will tell you they've never faced a more complex or demanding system. The technical features of production system have never been greater. Anybody who thinks agriculture is low tech has not sat in a $900,000 combine and looked at all the computers that are telling you what's going on. So the challenges for producers, though, I think include the fact that they're increasingly under a bit of a lens by the public. How was this produced? Are you affecting water quality differently? Water in the West is a very big issue, of course, for producers, but water quality and nutrient management has become a really key part of managing any operation. And again, it's more complex than it's ever been, but I don't think history will ever back up. It will continue to be that. So I think producers do a good job of managing within that environment.
Nitrogen and water bodies get into streams and lakes primarily because water moves from agricultural fields to those streams and water bodies when there are nitrates present. And nitrate is a particular form of nitrogen that isn't tied to organic matter. Two ways to get nitrates in waters. One is to apply nitrogen fertilizer, and those nitrogen fertilizers are generally nitrate forms, so they're easily movable. The other way is for the soil to produce nitrates. So all these soils have organic nitrogen in it, which is unmovable. During the spring in particular, when the soils warm up and there's water around, that converts organic N to nitrates, and then it moves. Nitrates are needed because that's the only form that plants can take up. So you have to have nitrates for corn and other grasses to get nitrates, but you can't have it moving out of the soils into streams and water bodies.
I think we can talk about the nutrient loss reduction thing.
Yeah.
And people Gulf of Mexico hypoxia is just people think a lot of nutrients coming from Corn Belt region. Illinois is obviously one, or always we are one of the highest corn production state, and obviously we use a lot of nutrients. I mean, there's a lot of runoff, leaching happening from our field, but this perennial grass, especially established in an edge of the field as a filter strip right next to the drainage ditch or creek, actually this grass can actually intercepting all the nutrients goes into the drainage ditch, or runoff, erosion happen, this can block it basically, and then significantly improve the water quality. That's another benefit about this perennial grasses actually.
So you would, if I'm understanding this correctly, you would likely advise farmers to plant this switchgrass and other perennial grasses into areas that aren't as good for corn and soybean production, but you would also advise them to plant in their drainage ditches and their ditch areas on the edges of their fields. Is that correct?
I mean, you see that some of the very advanced, just the people thinking about the sustainability, you can find 40 to 50 feet wide of the filter strip already out there in a lot in our agricultural land. I mean, some farmers enrolled in the conservation reserve program, which is CRP program, is a part of it, and they're helping, saving our soil or helping, just any kind of a nutrients loss. And based on Illinois nutrient reduction strategy, the plan, about 10% land it can be dedicated, per perennial grass, and then we can significantly reduce nutrient loss. I know this is not the, solution for everything, but it could be part of the, one of the practice we can mitigating, nutrient loss from our agricultural land.
Do you envision a future where folks will be intentionally cropping these grasses?
I see it. I mean, right now, other than the land in northern the CRP, there's no financial benefit, right?
Right.
Yeah, but if we can start to cut this grass as a bioenergy feedstock for the material, I think people get paid. I think a lot of people are more interested, especially land is not ideal for the crop production. And also we talked about, carbon credit. I think in future carbon market will, this grasses be maximize their, payments.
Could you talk to me about carbon credit and really what that means? Kind of backing up and explaining.
I mean, I'm not an expert in the carbon credit, but I think we talked about depends on the practice, the management practice. Some practice actually we're losing carbon from soil. I mean, obviously not ideal, but some depends on kind of cover crop, no-till, perennial integrated system. Actually, we are increasing carbon in the soil, which is increasing carbon sequestration. I think it depends on how carbon market set it. I think they'll make a standard. Okay, you have a perennial, you get so much credit on, as per acre base. You have no-till, you get the credit. You have a different management system, cover crop, and a double cropping. I think everyone, I like to see that future because we need to, reduce the carbon dioxide concentration in atmosphere, but still too early to say actually how much actually farmers get paid based on their practice in terms of the carbon credit. Yeah. But in the future, I like to see it.
If we did not apply nitrates at all, or nitrogen fertilizers at all, we would still have an issue with nitrates because of the soil conversion of organic N to nitrates. The only technology that we know of right now, if you want to call it a technology that can help with that, is cover crops. Because a cover crop, if it's in there in the spring, it's growing, it will take up the nitrates. So that's one of the ways that this problem can be addressed.
So what would be an example of a cover crop that we might see here in the Midwest?
So the way cover crops work in the Midwest, and if you look at the Midwest, it's primarily corn and soybean rotations. So from corn going into soybeans, what you do see is the most prevalent cover crop is cereal rye. Farmers plant it in the fall after the corn is harvested. Some people put it on with planes before, but mostly after harvest, that cereal rye then establishes itself in the fall, and then in the spring it starts growing in March and April. That happens to be the same time that organic N is being produced into nitrates, so it scavenges the nitrates in the soil and keeps it in the plant rather than making it available for runoff. Here's the issue with it, is that it's costly. So you plant a cover crop, and our estimates would say it's cost $20 to $30 per acre to plant it. And next spring you got to kill it because you got to kill it before you plant it. So that could be another $10. But say it costs $30 per acre, there is no return. So there's no higher yields. People hope that there is higher yields. There's no offsetting cost reduction. So it's a cost. That $20 to $30 is a significant part of the whole profit from an acre. And we've had some very good years and some very poor years, but on average, farmland in this part of the world probably returns about $70 an acre. So you take off half the profit. And that's not really sustainable from a farm perspective. So there either has to be some subsidies to farmers, or we have to work with the technology, lower the cost, and figure out some other benefits.
To summarize, there are numerous environmental concerns to consider as it relates to sustainability. Many large corporations, institutes, and organizations are exploring ways to operate more sustainably and educate employees on ways to be more sustainable in their own lives. This content was indeed simply an introduction to some of the major environmental concerns facing our global climate. Now is the time for us to do whatever we can in our homes and communities, in our financial and voting decisions, to move toward a more sustainable future.